Okay. We got 3 more projects, and then please stick around for the keynote tonight of John Fraser. These little documents that are floating around will give everybody a bit of an overview. So every project, there's a page to it. It gives you a bit of an overview, actually, of what the different studios are actually working on and who our guest critics are. Okay, so everybody, welcome, and please.
Hello, everybody. We're Attentional Integrity. I'm Fatin, Delphina, Jose, and Carolina, and we're in Patrick Schumacher's studio. As you all probably know by now, our studio brief focuses on structural lightness and an integrated interface between the vehicle and the house. And so, the site was located in Camden, which is along the canal. And a further interest of the studio was this concept of an assemblage, where you have 3 organisms: the human, the user, and the house. And we recognize the user as a dynamic user whose needs create a set of ever-changing conditions. And so in order to address these issues of flexibility for the user and to address issues of structural lightness, we see tensile integrity structures as the most ideal solution to work upon. And so Fuller says, don't fight forces, use them. And so we decided to do that by looking at these structures and looking at how they work together and have omnidirectional forces and create an equilibrium, which allow for a kinetic building that can start to move and become equal. So the concept of the assemblage, the human, the user, and the vehicle comes into play, and it starts to help make important decisions about interface and about relationships of space.
So our initial research was focused in the domino house. We analyzed the domino house like a new design for a house typology that was focused in the human dimensions, but also in the construction techniques and materials of the time, and also proposed like a new human behavior, a new space for a new user. So our first study was like, how can be the new domino house with the new tools that we have now, with the new structural design, and how can analyze and propose a new behavior for the user. So the first step was redesigning the structure of the house. So we took the main design of the domino house as a core, and we tried to earn flexibility, to earn free space and free facade. So we tried to realize all the structure to the minimum space possible in order to earn these characteristics. In this space, we start to study different typologies of a structure. So we focus more in the hanging systems in order to earn freedom, in order to earn deformation and kinetics. And our design process was very simple. We were always simplifying the structural analysis with the loads and the anchor points. With evolutionary topological optimization, we tried to find out the best path in order to transfer the loads to these anchor points or the ground. And with the structural analysis, we dimension these structural designs. We work with stress lines and in order to find out what is the safe material in order to reinforce these structures.
So coming back to the concept of the assemblage, the house, the vehicle, and the user, we were focused on finding parallel methods and a workflow that's very similar to generate the house and the vehicle and to allow the user to kind of integrate within them. So to start with the house, we started with looking at environmental forces about the site, and then we started to look at the load structural optimization to start to create the most optimized kind of paths for the location of the building with the characteristics that we desire. And in the same way with the user, we also look at the environment and the vehicle, the user and the environment, and we start to look at structural optimization to kind of create the most ideal and efficient space. And then when it comes to the third organism, the user, we were more interested in, because we're interested in the ideas of flexibility and anticipating a space that isn't based on identifying basically if it's a bedroom or a kitchen. We're more interested in the qualities of the space. So whether it's a public space, a private space, an active, a passive. So we started to look at the relationship between spaces and between them with each other and between them and the environment itself. And then we started to look at ways of, within the structural network that we created, how we can start to address issues of flexibility within this structure. So where to locate more public areas like leisure, where to locate more private areas like work, to be able to create the flexibility we want. So the site, as mentioned earlier, is in Camden. It's along the canal. And so we started to study kind of the main site forces that will help locate our building. So we have a neighbor. We have one neighbor on one side, and then we have a canal, and we have the road. So in our system, we have four main elements, which were inspired by the Maison Domino. So we have the core, then we have the kinetic slab system, which was inspired by the hanging system, the interface envelope, which interfaces with the inside and the outside, and then the vehicle. So within, you see you have the rigid core, which is the most rigid part of the house, and from there, everything that's flexible and dynamic can hang. So it makes it possible. And then you have the kinetic slab system, which starts from the top and starts to hang down through a network. Each one, depending on another, has tensional integrity, where they're always in tension and compression, and at the same time, they're laterally supporting one another. And then you have the interface, the envelope, which starts to move with the slabs and starts to interface with the vehicle and starts to mediate between the environment, providing qualities of light and public and private.
So with the input of the domino house, we start to analyze it on site with the anchor points and with the relationship with the road, the neighbor and the canal, and they give us a result of the best position in order to respond to the situation.
After understanding this flexibility, we started to see how we could, by means of weaving structure, could start like reinforcing or having like hierarchies in the different parts of the rigid core. And as we wanted to place the staircase inside this rigid core, we also started to see like how the constraints of having this input like of the staircase would start giving us like different possibilities like for opening accesses and bundling and structural bracing. And the rigid core sorry. The rigid core is generated with the constraints of the site. We have the neighboring that gives us the clustering of the foundation, the growth from the water. The 6 columns that weave the core start from the weaving from the foundations and until they come to the capital. Here will come again. Basically, like these six column cores have rails and that connect the trajectories towards the slabs and hold the whole hanging system. Sorry. And this is like the core as an object with the different parts, like the foundation, the 6 column core where the staircase is embedded, and the capital with the tensioning cable net that tensions this capital and is comes back to the core with a tensioning cable.
So from the core, which is the most rigid element of the entire building, comes the interior kinetic system, which is the slabs. So basically we start, as you see, we have the house generative, the structural input. And so basically we take that and we take the knowledge and we take the core, and from there we start to branch downwards, hanging all the columns and allowing them to hang off of one another to create a structural network. And then between them you start to create the boundaries and the lateral connections to stabilize one another. That generates our floor plans from the stress lines and the directions of the loads, that's how we start to decide where to break up our slabs and where to create the slabs that are able to move and the ones that aren't able to move. So the ones that are closest to the neighbor are completely static, and the ones that are also closest to the core are static because the core is the most rigid part of the house, so that's where also we have the MEP and all the services. So in terms of the relationship between the dynamic and the rigid elements, so the core and the slabs, we have relationships of services and we have relationships of circulation. The first one of services is the one where throughout these 6 columns, some of them are dedicated solely for MEP and to be able to feed all the different levels. And at the same time, the circulation, the vertical staircase, stops every 2/3, allowing incremental landing so that the slabs can start to move up to designated landings without having to break circulation. So as we see here, this is the building when it's completely state 0. And then you see how like each slab starts to move to specific landings and allows it to either become an isolated space or 2 can move together and share one landing and become a larger space, hence allowing the building to fragment and to become terraced and to basically shuffle around the position of the slabs. So this is a deeper look at how the slabs kind of deploy between one and the other. And so this starts to introduce the mechanical system that actually makes this possible. So basically the mechanical network, we start to have between 2 slabs, the lateral connections which start to help stabilize laterally, but at the same time they're actuators which start to help equalize and balance the slabs as they move up or down. So as intentional integrity, a building has to always be in equilibrium, and they're always depending on one another in tension and compression. That's what happens with these lateral actuators. And at the same time, we have screw rollers that kind of run up and down the rod, which is the column, allowing this movement to be propelled. So this is the slab and column composite. You have the main rod, which is basically the thread that your screw roller runs up, and then you have your main slab structure, which is optimized by the structural optimization software, reduced to the most minimum possible material. From there, you have the linear actuators that connect to the slabs next to it on neighboring. So here we see the screw rollers are inside the slabs, and they allow the slab to move up and down. And then we see that the actuators kind of help the slab also move up, creating another support, and they behave between one another. So with this system, we have 4 main kinetic kind of possibilities. One is allowing the slabs to move up using the roll screws. Another one is allowing them to tilt using actuators pushing the slab from the core. A third one is combining the first 2, allowing the slabs to tilt and move up in order to maintain a level, allowing it not to break circulation. And then another one to create outdoor spaces is to tilt and shift outwards, the column becoming an actuator to telescope out. So here we see that spaces that move up can move up through the rod. And so the relationship between the column and the slab is more of a fixed anchor position, and between the core is more flexible. Another one is where the core pushes the slab, allowing it to tilt. The relationship between the column and the slab are also anchored, so it's always in a 90-degree relationship, allowing the slab to move in a more stable way, being supported by the lateral actuators. The third one is the combination of the 2, allowing the point closest to the core to always be at level with the neighboring slabs in order to make circulation easier. And the final one is for outdoor spaces where the slab starts to push and interact with the external interface, the skin, to create outdoor spaces being mainly pushed from the core. So the spatial transformations that are possible are basically a combination of this interior spatial configuration and then the skin, which is the environmental mediator. So we see that we can have outdoor terraces, you can have double heights, you can start to even close up the entire building if you want to as a safety, a new alarm system. And then you can start to create different areas of public and private. So this is like a small catalog of just a number of the chosen possibilities that you can have. You can start to have, and you see with the gradients, how the levels of public and private start to change throughout the building as the slab configuration changes. So within here, like a more detailed look at the building, you start to see how, like, when you start to break up the slabs, and you have the interstitial, which is the space between the 2 slabs that allows basically people, first of all, not to fall through, and at the same time, it creates lateral stability. You can have visual connections between top levels and lower levels, double heights. You can even interact with the water level. This is the third level, which is the closest to the core, and here it's the most private. So basically, you have smaller levels that are in cantilever and don't move, and then you can have visual connection with the lower level, but at the same time, you have privacy. This is a more public space where you can also interact with the lower level, but at the same time, it's more intimate, but not as public. And then we see how the slabs start to interface with the skin and how they start to connect to the skin, and as they move, they start to stretch.
In terms of the interface envelope, it works as a two-layer system where one of the layers deals with what's happening inside the house with the moving of the slabs. It's designed to fold and unfold as the slabs move up and down. And the other layer deals with what's going on outside with the lights. So it has different degrees of transparency to address this issue. So the inner layer is generated from the boundary of each level. So what it does is it takes into consideration the footprint of a level, and then addresses the level of its neighbor level, and then it deploys through mesh relaxation. So in this way, we get a membrane that is able to fold and unfold. So for this, we developed a pattern criteria where we can have different degrees of transparency and different degrees of flexibility, basically. So the slabs, the facade is generated in 3 different levels, and each one is attached to each level. So they're separated in 3 different areas. Here we can see how this mesh is deployed, and it addresses the level, the boundary of the level, of the superior level. Here we see what we get with this. Instead of, as opposed to getting a flat screen, we get something that is more spatial and deals with the conditions of the slabs. This is also able to release its anchors and lift. As you can see, when the slabs move up or tilt, we are able to either have just the movement or also create these openings by releasing the anchor points. This is the outer layer that is like a shrink-wrapped membrane that it's anchored just in the top and the bottom, and it has seams that work as reinforcement in some areas, and they're directly connected to the core. For the transparency of this membrane, we did a site analysis where we basically take into consideration the natural light and the views. So as you can see, as here, this corner in the south is the one with the most light, and it's also the one with the best views. So we get a gradient that is more clear towards this corner and darker towards the other, as also in elevation. So by the superposition of these transparencies and the seams, this is what we get. So this membrane that addresses what's going on inside and also what's going on outside. And this is the interaction that we are able to, when they're working together, and with the slabs, the inner layer and the outer layer, we're able to create these deployments, and also this slit, when it matches with slits, we can create terraces that are completely open. Since this fabric is only anchored towards the top and the bottom, whenever the slab moves, it's able to rearrange and adapt to it. This is a view of the 2 layers working together with the environment and the slabs.
So with the same system that we use for the house, we try to generate the vehicle. The difference is the input. We work with ergonomics, and in this design we propose like the minimum space in order to a person to drive. So we generate an internal pod, and the envelope we generate it through the parameters of the gravity and work through against the velocity.
So this is the first iteration of the car, where we started to understand the paneling and the interstitial flexible skin between the panels in order towards achieving flexibility for a transformation. So by means of this, we started to see how these panels and the skin could work together towards achieving more aerodynamic inputs. This is our second iteration of the vehicle. It's a four-wheel vehicle where we start understanding that there is a skeleton that works with the ergonomic of the body, and with a wrapping skin that wraps the skeleton, where we have places where the skin is more flexible and places where it's less. This is how we understand the layering of the vehicle with its skeleton and the wrapping skin. This video shows how we see how the skin can be stretched towards achieving different configurations for the car when it's moving. This image shows how the skeleton performs. It has these nodes that connect to the skin, and in a way kind of stretches the skin towards achieving that flexibility. And this is our last iteration for the car, where we started to understand a three-wheel vehicle. And what we are studying in this vehicle is the transformation between a three-wheel vehicle becoming a two-wheel motorcycle. We achieve this by designing these wheels that have two directions, so they can kind of come together or separate, working with this flexibility of the skin together. So as a person, in order to ride a motorcycle, has to change its position of the seating. We wanted to work with a gyroscope system in order to have the comforts of a three-wheel vehicle or four-wheel vehicle, but have the flexibility of a motorcycle. So we're proposing this electric vehicle where the where the electric battery is in the back wheel, that is the main wheel, and directs the electricity towards the panel, the control panels, the front wheels, and the gyroscopes that are positioned under the seat, where the center of gravity is. Here we started to see how the skeleton of the pod would start being designed from the ergonomic of the seating towards wrapping the human. And this is understanding aggregations of possible two-person vehicle. This is a linear aggregation where we can have a two-person vehicle to get inside the same pod. While this aggregation shows how two vehicles could start working together, but separately, right? So they would cluster and continue. And so then, further on, we started to understand this vehicle, working with the interface, and how it would start to have to open up towards to match the skin for it to enter the house. This is basically a detail of how we understand the components that are needed for the vehicle and also for the interface. This is an exterior and interior view. We are understanding the exterior of it and also the interior. When it interfaces with the house, it can become furniture, as a seating place. So this is a video that shows how we are understanding this interface between vehicle and house. It's what we're trying to say is that it's an optimization of space where there are no need of a garage, because because as the vehicle and the skin can match together, there is an optimized space. So the person like enters the house sitting and just standing up. So this is how we see the interface of the future vehicles. And this is how we see the interior interface in relation to the house. And to finish up, we understanding the kinetics of the slabs. We also worked with furniture, where we also took the concept of the gyroscope, and we started to design this three-frame chair, where the outer frame responds to the tilting of the slabs, so kind of rocks, and the two interior frames, frames work to stabilize the human that is sitting down. So it's a game between house and human. And this video shows how we are understanding when the slabs tilt, how it all becomes a dynamic space. And to finish up, this is a very quick video. That's all. Thank you. Let's go on.
Okay, so as far as the physical models are concerned, this is a larger sectional model showing the core, the slabs, the real relationship between the core and the slabs, and how they're all open slabs in how the slabs and the network of the columns are depending on one another. You see the top layer of the slabs here, and basically the stretching that mimics the stretching of the skin between the slabs, and how the relationship between the slab and the skin are interdependent. And this is a smaller version of the core, showing just the hanging of the slabs off of one another. And this is an earlier study of the core, just looking at the massing of it. And then again, more core studies showing bracing and tensioning and basically methods of structuring, of optimizing and creating lateral kind of support and bracing. And then these are more these are basically structurally optimized slabs, and basically you run software and start to create the paths of the loads. This is again another study of skin and how you can start to have wires and stuff going through the skin to create the curtain effect or the unveiling for the outer spaces. And this is an earlier study of the skin. And then you have the furniture, and then you have just versions and iterations of the car. And then to conclude, you have the slabs. This is one of the earliest versions of the slabs, basically in situ with the interstitial, and how they start to create circulation as they stretch open, and how they start to have visual connections with the bottom.
Just jump in. I'm curious about the behavior of the house specifically, and whether you guys can kind of speculate on a house that, say, its occupants go on vacation for a month. There's nobody in the house, and I'm curious how the house responds to that condition. What would it do?
But we thought that the slabs could just start to shrivel and shrink up and start to just close up like a flower. So basically, it completely limits visual connection, and you can't permeate the building in any way.
Yeah, it's a good answer. You're it's an interesting answer. I'm curious about the word optimization. I actually started counting. You said it probably 25 to 30 times in your presentation. And I'm actually curious what that means, right, with a structural, and it's not purely with this, it's my own work, trying to understand and to figure out what that might mean. And I'm curious a little bit about these moments. I mean, it's a fantastic project, right? It can do so much, right? And it's extraordinary, extraordinary thing. But I'm curious as to the sort of behavioral sort of motivators, let's say. And I'm also struck with, you know, that you guys ended your presentation with those three shadowy figures on the couch, who don't necessarily seem to be communicating. You know, they're sort of neutral, let's say. And I'm curious about what kind of social patterns would begin to emerge out of occupants living in such an environment, and whether your notion of optimization is cross-linked with those motivators. I find it, I find the potential of it intriguing, but I'm not yet. You guys really, in a way, haven't told me. I'm kind of fantasizing so much right now about all this, really perverse, spectacular potential, but I don't think you've told me enough, in a way, about what you are speculating on in terms of the potential kind of behaviors here. I mean, what would happen? I mean, we're in a room right now. It's ultra stable, right? We're incredibly dynamic, in this room. But what would actually be the result socially? How would we self-organize? How would we communicate in such an environment? And that, for me, is one of the most intriguing questions, in a way, about the project.
Well, we kind of see it like a play between the house and the user. So basically, the house changes with the environment or with the user for the user's needs, but then the user's behavior changes with the structural kind of game that the house provides. And so, for example, because they're hanging, and you can start to sway, and so like a user in one space can start to recognize the presence of a user in another space just from the swaying of a space. And at the same time, in terms of the furniture, when the slabs start to change to allow the space to configure for the user's needs, the slab's body positions change, basically to adapt to how the space is changing for the user. So they're kind of working together in a way. And it's also partly unconscious on the part of the user.
Good answer.
On? Yeah. Congratulations, like an amazing amount of work you put there out there, really fascinating. And also, I think the most elegant car accident I've ever seen, a car crashing into a house. And I want to pick on that, what you started the conversation, social interaction. We were used to the idea that, so we leave the house, we bump into other people. We meet people in the city, we fall in love in the city, and so on and so on. So what's your point, what's your answer about interior private, exterior public? Because were you generating this continuous 21-degree space where you're not necessarily having to meet anyone anymore? Do we like that, or how do we think about that?
Well, public and private is kind of relative in a way. And so we see it in terms of, in a way, public and private is more about the proximity between you and others, not necessarily between how far in they can see or how much they can see. But at the same time, the skin starts to help play with the issues of public and private. So the slabs maybe start to stretch the skin vertically to allow more views, more light, but at the same time, you have more interior spaces that start to, basically it's a game of terracing. So you can visually, you can see throughout the entire house, but you're kind of hidden in one corner or, yeah.
Also the fact that, the house can be kind of see-through in some areas, and also because the partitions are not necessarily there all the time, but you start to interact with the house and get to know the house, and if, for example, if you would like a space that is more enclosed, you know that there are a few constraints, but that also that's what gives it its charm, Like you say, okay, if I want an enclosed space, then I will have to lower the height, and the blinds will come together, and it will become a wall, And so I guess that's also what makes it. It's about the interaction between the house and the user also.
Yeah.
It becomes an interface.
Maybe I should precise a little bit. I think that on the architectural scale, that's fantastic. The gradients, amazing. I was more referring to, on the relation to the mobility concept to the car, which is a public domain basically. The car is, at least the context is public. That was I was referring to, not inside the house. The house is amazing, like how you.
I'm just thinking of the references to things like Charot's Maison de Verre and Paul Nelson's Maison Suspendue. And the thing that comes to mind most powerfully is that in all those projects, very little movement gives you the idea that everything swings and changes and moves. And obviously this is going through an experimental developmental process, which is what you're about. But in fact, you could achieve probably all the poetics, which is setting colleagues' imaginations racing, with actually only a fraction of this moving and changing and developing. So I suspect that if you had the time to go through a period of refinement and very heavy editing till it was down to the absolute core of a few small things moving and changing, you might achieve not just the same effect with less effort, but actually more, that even more of an intense experience. And I'm also speculating, like everyone else, about the interaction of the group dynamics, because we're looking at a model where some parts of it are extremely carefully and elegantly built, and other parts are relatively throwaway. And so I'm getting very mixed signals about what the priorities are and what the enthusiasms of different people in the group might be for parts of this, for this project. Not that that takes anything away from it, it's just that I feel it's one of those projects where we're all racing in our minds to do something with it ourselves. And the minute you get a group of critics possessing the idea themselves and wanting to take it on, you realize that you've achieved a significant amount. But of course, what we're all also thinking is, if you had that much more time, how much more refined and elegant this extremely poetic idea could become. So I think it's just like a very elegant demonstration of the potential of something quite extraordinary.
I want to maybe continue on this a little bit, is that obviously I will echo all the congratulations of the gigantic amount of work you guys put into this, but seeing over and over again these threaded rod mechanical kind of actuators, I wonder if you didn't lose a little bit of your tensional integrity, that these kind of things could have perhaps also happened in a more pure compression tension kind of way by these pneumatic actuators and so on, and to keep it in the original models that you looked at there, the very Le Ricolet kind of stabilized things. And so linking to what was just said, I think if you then strategically place how you start to tighten and tension and balance things, that you could achieve a lot with systems that don't need to resort to the literal very interesting references that you found, but that keep within this tensional integrity that you stand for. So I think if you push that a bit further, then there is absolutely nothing to say. Then we want these crashes to happen in your skin indeed. About the skin, by the way, I just have a question. It seems in your structural optimization that you use them to stabilize your building. So what happens when you open them up? Your stabilization goes away?
No, they're non-stabilizing. It's working, it follows the motion of the slabs.
All right.
But if you remove the skin, the slabs will still...
Okay. Yeah. By the way, it's happening now with a rigid, or it just happened. So there, I think you could have gone that one step further. And I'm thinking particularly also with your car. I was thinking of you must have seen Axel Killian's and the Media Labs car with these muscles and these very flexible. So that's the direction I was referring to. But great work. Congrats.
Hi. I think the project's fantastic. I think the point is well made about maybe thinking about just some of these elements moving and getting the elegance in terms of the design rather than an over-complex system. But clearly you've understood the structural aspects, and I think the importance of the interaction between these different parts, which is key to the structure of the system. But one thing particularly interested in is the facade, coming back to the facade, and how that deals environmentally with the different situations. I think it can clearly move with the floor plates and it can adapt with the floor plates, but how does it deal with the different seasons, the different solar gains? Has there been any kind of thought along those lines?
There's where also the user comes in, and it's like work basically as a blind system that it is controlled by the slabs. So the user will be there also like compromising and adapting, and also the exterior membrane deals with the light, and we would like to continue the research into something that...
Yeah, I guess what I was saying, it would be a shame to have to close the slabs up in order to control the solar issues or the environmental issues. It'd be nice to be able to, those two things to be, you know, separate, if you like, and dealt with independently rather than needing to close the building up one side in order to deal with those kind of issues.
Yeah, I might even actually take the opposite tact in a way, because I think the project sits in this kind of strange position between very specific and very generic. It's generic in the sense that because everything moves, you could kind of be anywhere and achieve everything that you need to. And to me, it's almost a weakness. I think I can understand the tendency towards, okay, if I'm here, I also want to be able to have it tilt and then open the window. But I think the project could have actually a little bit more irony and a bit of power between, okay, if you want to close the blinds and be hidden, then something else happens somewhere else where you have to make a trade-off, and that you could have a different type of intent, perhaps more social, about how you are forced to interact with the city. Because yes, if you choose that all of your floors are down and you have this giant, it's an incredibly oversized house, which I think is what John is talking about. Not only does not everything have to move, if everything has such capacity to move, you don't have to move anymore. There's no real reason to go upstairs in your project. You just change your downstairs into what you want. But I would like then, if that's the case, that you have to do some kind of give and take to the city. That, yes, okay, I'm having a huge party and I've moved all my floors up, but in so doing, I've given back to the city the ground floor, or however, some sense of friction in the project. It's a little bit too much. You say, we could do this, and we could do this, and we could do this, and a new mechanism comes and everyone is happy every time. But I think there could be more disagreements and arguments about, no, I want the floor down, damn you.
I just want to come in on a few of those points. But first of all, congratulations, I'm very proud to see this, and I feel that the initial ambition to show what the 21st century version of the Maison Domino would be in terms of its lightness and freedom and transformation capacity, some of the visions of the modernists on a new level executed. But I think that the degrees of freedom which are, I mean, it's great that people think there's a total freedom. And there is the image and delusion nearly of total freedom, but there's obviously a whole series of constraints built in that, the ranges of what the slabs are moving. And there's also, I think, an economy of, you know, if you think of moving slabs, once you have the hanging mechanism, a little bit of lateral push from a piston can shift a whole slab and reconfigure. So there's also this ambition here to have the actuation very, very simple and with little energy, yet the transformation being surprising. And I think, of course, yes, there is this. On the one hand, more freedom would imply that the systems are separated out and become independently variable. But here's a lot of an emphasis of having dependency networks. And of course, they need to be orchestrated, and sometimes they might have to be cut. But there's also this image of every action having a reaction and repercussions is radiated through, which in the end is also, I think, an element of social recognition, that there is an awareness which ricochets through the systems of somebody's present, of some conditions and environment changing, of a car entering the house or not. That's a beautiful idea of leaving the car kind of like a coat on the edge of the house. So I think that I think was something which works very beautifully. That there is the sense of limitless freedom, but there's a very clear constraints which, within the various elements, and there are some fixed slabs also. Maybe that could have been emphasized more, because I believe in exactly what John was hinting at, an economy of means, and something which isn't also further be explored, this idea of psychological and gestalt and figure transformation, which a small object and physical transformation would trigger in terms of the visual reconfiguration, is something we would have to be more explicit, more investigated, I would think.
Something I want to pick up on, I mean, there's a lot of invention in the project kinetically, and a lot of people commented on all the different interests in that, and I support that. But I also want to pick up on a counter-argument for that, which is that that most of the interaction technology that's been developed, say, over the past 20 years has been based on electronic and multimedia technology. And at the moment, the project's really arguing that, like, in fact, even the word interaction, I think, is perhaps not the right word. I think it's more about you want dialogue between the inhabitant and the building, because interaction implies much more of a two-way conversation than what's really going on. Like, what you're trying to do is adjust different levels or adjust for different activities and then register that through things like Facade. I think the car becomes perhaps the most productive kinetic thing. But I think as you do the book, one could question what interaction is and also where it should happen, because it's actually, by default, we normally operate through, I would say, more horizontal media. You know, things like walls, screens, doorknobs, you know, conversations. They're very much a horizontal thing. And all your kinetics mainly focus on, you know, the floor slabs and things like that. So what happens when one floor changes height relative to another floor and I have eye contact with someone, or I can see the furniture across the other side of the room, or a view opens up that wasn't there before. These types of things can be documented. I think they'd be invaluable. And also a little bit of faith in the electronics as well as the mechanics. For instance, the car, I think, is, for me, one of the most fantastic parts of the project. I really like the way it opens up and you enter the house, and also the way that you consider it something that can be added to, you know, like in two axes. That's pretty radical. But there's one problem with the car that I really see, and it's the steering wheel. Because if it's an electronic car, it's drive-by-wire. I can have a joystick, I can have a control joypad or something. I don't need a steering wheel. And I think it's the same attitude in the house. Like, you can drop like, for instance, these tilting floors with the crash test dummies on the seating. It's a little scary, right? But the changing of the floor level itself, there's a good argument for that in the way it changes the sectional relationships in the space. But I don't think you've yet argued for a reason for the floor slabs to tilt and things like that. So yeah, some great work, but just make sure you package and document the qualities and the kind of attitude that you have towards each of these ideas of either responsiveness versus interaction.
Sure, can I say something? Opportunity talk. I mean, I just kind of want to, a lot has been said, and I think in many ways I support what's been said. But I think in terms of looking at the project, I think when you sit in front of this model, it's symptomatic of that the strength of the project is it's in prototypical interfacing, like car to the building, actually dematerializes that distinction in some way. When you start to develop the slab to the partition, you do it to the exterior, but one would wonder, like some of these early models were hinting that that same kind of strange cable network could reside within the core, because it seems like the project has been pushed in one sense now with one resolution, but if you go back and now start to extract what this kind of continuous puppeteering could happen, because the dominance of the core and the superstructure on top seems to somehow really dictate the general kind of overall volume. But for example, a push or a pull here could miniaturize the building, and it could potentially always disappear too. Like I'm thinking the same slab kind of structure that's happening on all levels could also happen on the superstructure. It would just have a very different kind of regulation. And I just think in terms of how you look at the project, I think it's important. When I look at it in section, it gives me a lot of things that are left to the imagination. When I see it as details, then it's not something that gets distributed in one way, but potentially there are other opportunities. So I think if you look at it holistically, it's brought to a certain resolution. If you look at it more from a prototypical perspective, I think the same way that you gain some of these kind of interesting and novel interfaces, you could question what that really means on the interior. You could question what that means subject to a lot of different kinds of issues that have been discussed over the day. But I wouldn't see it as a kinetic sculpture that we live in, because I think the comments of the passive occupant shouldn't always be like space on demand. The building should actually proactively speculate about what those things actually are. And it should have observation, and it should be more conversational. And I think if you do that, then you afford very different opportunities. What is embedded in the system itself? What is embedded in the material choices that you're using in terms of how one occupies soft surfaces that are the interiors of the car? When they're sort of unfolded, what opportunities does that now actually offer? So that the car doesn't really become a seat that basically is attached and fixed to my facade, but the interior of all of those surfaces become opportunities for others and deeper, more speculations. I think that's really important. Now you can sit.
Can I just, another, are you going to respond? Or? I guess one thought I had just, picking up on that is the, maybe another sort of missing speculation that I think could really be fed back into this, that would inform the project, is beginning to think about what the, like the operating system is and what it actually looks like. What's the algorithm going to look like here? Is it autonomous? Are you providing feedback? And how do you actually provide feedback? Is it a gesture-controlled house? There's tons of people right now in our lab too that are looking at these headsets that are literally reading your mind. They can tell if you're nervous or excited, etc. And so what does that begin to feel like and kind of look like in a space like this? Because you really, in a lot of ways, that's the missing piece of this, let's say. And yet you've got a system that can kind of do so much, but you're missing kind of the half of it, the kind of the skinning of it. I mean, it would be really disappointing if I had to pull up my iPhone and sort through all my apps and be like, okay, floor, and hit a button and the floor goes up. There's going to be a much subtler kind of underlying behavioral kind of system here. And that would really, I think, begin to tune the space and really provide that kind of conversant kind of atmosphere that I think this environment kind of opens up. And so it's just sort of in a way, I think perhaps something that you could begin to speculate on in the next phase. And another thought would be there were some diagrams you had that were they were structural analysis diagrams of kind of hotspots of tension or compression in your structure, and those are really fantastic and they're really beautiful. But you could do the same thing with behavior, right? You could find gradients in the house that might be related to heat, as an example, right? Comfort, sound, all the things that humans kind of want out of our environments, silence, etc. So you could really overlay that level onto it. For me, then it would really begin to live up to its potential.
I think that's why it's a very important point. And emphasize we haven't debated it so much here, it's true, but we have debated earlier projects. We've been looking at that. Yes, the house is an active participant. It's a prompter. It cajoles people. But it's also then kind of trained, and there's machine learning and an evolving set of options it might cycle through. But there should always remain a kind of random degree of randomness in its offerings to keep mutations on the throw mutations on the table of what yet to do and what configurations to generate. So I absolutely correct. It wasn't worked on. It wouldn't be the 5 menus and space on demand. That wouldn't be the spirit of this, because it's so much of a kind of a also the combinatoric explosion which relies on the degrees of freedom which are there allow for that to be much more than you could ever put on a menu. And I think that's very important, that it becomes an evolutionary process. That's why you also included the population and the actors as one of the elements and put them on the same level. I mean, we haven't done that here. We've done it in previous studios where we involved crowd modeling strongly, and the way, you know, they just become another set of agents, and they're in the simulation they're all human actors and agents and other pieces of geometry, and they're all agents in an overall system which puts all this onto the same level, and that's very important. I think, which maybe should be in the book as a kind of clarification of the spirit of the interaction processes. Okay.
Just one really quick comment. In the Maison Domino, Corb doesn't show the walls because the point is that they can go anywhere. For you, you don't show the walls because you don't have them, and you don't need them. And I think that's actually really important for you to emphasize, that this is now a house that doesn't need walls because it has these other behaviors.